My name is Tony. I'm working on the topic of human and obstacle sensing with mmWave.
My name is Shengwei, and I also can be called Harry. I'm working on the visible light parts and also with the drones.
I'm Florian, and I'm working on robust communication and sensing for smart environments.
Our project 6thSense is divided into 4 work packages, and the first work package looks at different technologies and frequency bands for joint communication and sensing.
So in work package 1, we are trying to figure out sensing across different parts of the spectrum. Very low frequency, very high frequency, and even visible light.
The work package leader for this work package is Marco Zuniga from TU Delft.
And that work package builds the basic primitives of the system. For the next generation of the internet, the signals that we have in the air are going to be useful not only to send information, but also to sense. In my work package, I need to lead the construction of those basic primitives, those fundamental building blocks that will be used later.
I'm working on sensing human obstacles with mmWave. To explain this, I'll bring up my grandma Maria. She's old, she lives alone. What to do to keep her safe? The answer is actually already at her house. With all the Wi-Fi communication signals, we can sense her activity. The communication signals that are of higher bandwidth, shorter wavelength, enable us to perform more fine-grained sensing, such as sensing breathing, heartbeat, and small and subtle movements. The goal of our project is not only to make this work for grandma, but also to millions of households, to hospitals, and to nursing homes.
But you can also think a bit bigger. New factories where you have thousands of small sensors using high frequency bands. This is exactly what enables very high sensing accuracy when you want to localize each of the moving robots.
I think we can think this more broadly. When we're talking about Wi-Fi or like more radio stuff, we always have to put a new device everywhere. Now we're also developing this new technology, just simply using lights to transmitting data, which more we also want to use to transmit for the robotics localizations problems to get a really precisely millimeter errors localization for robotics applications. And also we can use all these lights to detect whether the granny is getting hurt or something.
The students already reported novel algorithms, for example, to obtain more accurate localization or different mechanisms to transmit information. So we expect that if in 1 year the students were able to complete so much in terms of building prototypes and developing algorithms, we expect that over the next 2 or 3 years the progress will increase even more.
One of the important things of this network integration is like thinking about the standardization.
Standardization is important because if you don't do it, you're going to have chaos.
In work package 2, we would like to take these solutions to our actual networks.
Cellular communication is of course of very large strategic importance for Europe. We have been leading this field already since the 2nd generation, and now we're already talking about the 6th generation, so it's important for Europe to keep leading the innovation. And as joint communication and sensing is a very important topic for 6G networks, this project specifically is also very important for Europe.